For section 2.3.3, we're going to kick up our analysis a dimension, and instead of talking about the area of a rectangle, we're going to learn about the volume of a rectangular prism. Whereas area measures the two-dimensional space that a shape takes up, volume is a measure of the three-dimensional space that a shape occupies. If we look at a rectangular prism, basically it's a box. It has length, it has width, and the third dimension we normally represent as height. The volume of the rectangular prism is length times width times height. So you can see the formula for the area of the rectangular base there. And when we multiply it by the height, we figure out how many cubic units fit inside that rectangular prism. Sort of like if I could fill up that box with sugar cubes, how many cubic units would fit inside that box? This is what example 5 is dealing with. It says the volume of a suitcase is 1,920 cubic inches. Cubic means that we've got a three-dimensional measurement. The height is 12 inches and the length is 6 inches longer than the width. Find the dimensions of the suitcase. Now I'm just going to use the diagram that I have over here to the left to label the dimensions of our suitcase. We're told that the volume is 1,920 cubic inches. The height is 12 inches and the length is 6 inches longer than the width. Well, if we use W to represent the width and it tells us the length is 6 inches longer than the width, then we know that the length equals 6 inches plus W, 6 inches longer than the width. So our goal is to find the dimensions of the suitcase. Dimensions means we need the length, width, and height of this suitcase. So if we use our formula, volume equals length times width times height, we can plug in what we know. So the volume is given to be 1,920 cubic inches. The length, we're not going to model as L, we're going to model it as 6 plus W. The width, we're going to model as W, and the height as 12. Notice we have one variable. If you find yourself writing an equation and you have more than one variable, then something is wrong. We should only have one variable in order to solve these equations. So we need to solve this quadratic equation for W. At this point, it doesn't look quadratic. But as soon as we multiply the right side out, we will have a W squared, and it is quadratic. Now, another thing that I'm going to do before I multiply the right side, I'm going to go ahead and reduce it ahead of time. I'm going to divide both sides by 12 so that I can cancel one of those factors and reduce our numbers a little bit. Smaller numbers are usually a little easier to work with. So dividing that left side by 12, we end up with 160. So now we have 160 equals 6 plus W times W. We can break up these parentheses with the distributive property, even though it sort of feels like we're doing it in reverse. We end up with 160 equals 6 times W plus W squared. Very clearly now a quadratic equation. We have 4 methods we could use to solve a quadratic equation. However, the square root method, that fast, efficient, simple method, does not work on this one because we have that W term. So we need to go for either factoring or quadratic formula. You could also complete the square if you felt like it. But either for factoring or quadratic formula, it always has to be equal to 0. So let's collect all of our terms on one side by subtracting 160 from both sides. And we end up with 0 equals, those cancel out. We've got 3 terms over there on the right side, and I'm going to rearrange them in descending order. W squared plus 6W, now we have minus 160. So we're going to go ahead and factor this. You could also apply quadratic formula. I recommend practicing factoring. If we do our sign analysis, we can see we keep running into this case. If this is negative, it tells me the signs in my binomial factors have to be different. and the first sign tells me the biggest factor has to be positive. So we need two factors of 160 with a difference of 6. Very easily, we could quickly discover 10 times 16 is 160. The biggest number is 16, and therefore it has to be positive. And notice the difference of those numbers is 6. So if you FOIL it back out, you will end up with the same trinomial that we began with. So at this point, we set each factor equal to 0, and we solve for w. The first factor leads me to a negative solution. That doesn't make sense for modeling the width of a rectangular prism, or in this case, a suitcase. So the only answer that makes sense is w equal to 10. So keep in mind, negative 16 is in fact a solution to the original equation. It just doesn't make sense for our particular application. So the only answer that we will report as a viable solution to this problem is w equals 10. So now we are ready to report the dimensions of the suitcase. The height was given as 12 inches. We just calculated the width to be 10 inches. And notice, to calculate the length, we're just going to plug in, what we ended up with for w. So the length now is going to be 16. When we respond, we want to make sure and include units in our answer. So in conclusion, the width of the suitcase is 10, and remember units, inches. The length is 16 inches, and the height is 12 inches. That was given, but we'll include it in our answer just to be thorough. Let's double check before we leave this problem. Want to make sure that, hold on. Okay, fix the calculator. Let's make sure that our answers solve the original equation. So I'm going to go back to this, and I'm going to plug in w equals 10. So working on the right side, we have 6 plus w, which is 10, times w, which is 10, times 12, and we're making sure that that leads us to 1920 cubic inches for the volume. And it does. So we have verified our answer, and we can be confident that it is correct.